Everyone, welcome back to the AMS Automotive Evolution Summit with me, Christopher Ludwig. Great to be back here now, moving from our earlier topics where we talked in depth on sustainability, now coming on to one of the most important issues across the industry today, AI and data, machine learning, looking at how to optimize these processes in automotive production. It's come up again and again in sessions over the last 3 days. The importance of data management, data storage and processing to allow for more predictive planning, maintenance, and decision-making across manufacturing. And we increasingly see opportunities for machine learning, for example, to address things like quality and reduce errors. And at the same time, we're also seeing more engineers, manufacturing engineers, using machine learning and data visualization to help OEMs make strides in product development, in bringing components and products quicker to market, testing and simulating changes, and of course then integrating that into the manufacturing process more seamlessly. And in this session, we have the opportunity to look across various parts of that process, both on the product development and manufacturing side, as well as in quality control. We're going to hear more about data, how data can be shared across multiple parties for analysis and learning, and of course some of the difficulties and challenges that come with that too. And we'll look more into the detail of machine learning in automotive production today. Also, we're going to look at issues around connectivity, opportunities, and things like 5G. With that, I want to introduce our expert panel because we really have some wonderful experts with real life experience and great projects to discuss across this. Our first expert in our panel discussion, he's the Chief Executive Officer of Secondmind, a machine learning specialist working with OEMs to speed up product development and manufacturing planning, more than 20 years experience in product and service line, often in focus on machine learning, mobile, and technology. I'm very pleased to welcome Gary Brotman. Gary, great to have you here and have you join our panel.
Thank you, Chris. Great to be here.
Absolutely. My next panelist I'd like to introduce holds key roles in quality and maintenance for BMW Mini, where he's also managing BMW's input for Weld Zero project, an initiative that we're going to be talking about in some detail during the session, which strives for a zero defect strategy in welding. He's been with BMW Mini since 2001 in various maintenance, joining, and welding roles. Ladies and gentlemen, I'm very pleased to welcome Tim McGrath.
Hi, Chris. Thanks for having me here.
My pleasure, Tim. Great to have you here. Also joining us from ATS, and someone also working in partnership with Tim to help capture some of that weld data that I mentioned. She's also represented a UK government-supported 5G-enabled manufacturing consortium, which explores use cases for 5G private networks in production. She joined ATS in 2019, where she helps drive Internet of Things solutions and industrial automation. Very pleased to have with us Katerina Mouliadou. Katerina, so nice to have you here.
Thank you, Chris. It's my pleasure.
Indeed. And last but certainly not least, completing a trilogy of partners related to the Weld Zero, but also doing some very interesting research, Dr. Peter Wilson from Lancaster University is joined us. He's has a career in engineering with Rolls-Royce and is a senior research associate working with research technology, OEMs, and suppliers. So very nice to have Dr. Peter Wilson from Lancaster University join us as well. Hi, Peter.
Hi, thanks, Chris. Good to be here.
Great. So great to have all you with. So we're going to be, we'll have a panel discussion across a variety of areas. Audience very much encouraged to submit questions as well. I want to start with a little bit of warm up, if you like, on the topic. We hear a lot of excitement, perhaps hype around machine learning, AI, big data, especially in automotive development and production. So what's right versus hype? Where do you see relevant, useful applications? And where do we still have a long way to go? And Gary, as someone who spent a long time in machine learning, I'd like to start with you on that one.
Yeah, it's a loaded one, but I'll try to make it quick. First off, I think we're past the hype curve, and we're starting to see more practical applications in machine learning. There's been a lot of experimentation, beginning to see productive exploitation. The areas in automotive that I've watched even before I was the CEO of Secondmind, to see automotive embrace machine learning and artificial intelligence for ADAS and autonomy. And I saw that as a catalyst for really the industry moving much faster than it had previously. Traditionally, there has been basic probabilistic modeling and statistical analysis brought to bear when it comes to the design and development phase, where system design and calibration of engines, et cetera. That's an area which has been, I guess, the road's been paved for a while, but it needs to be repaved with better tech to deal with a mountain of complexity that's coming with the software-defined vehicle. I think the things that that still remain a little bit murky and like a myth is what we're talking about today is data. And there's a myth that you must have more data to be effective, or you must have big data to be effective. I think it's really about the right data. What we practice at Secondmind is actually optimizing around data. So when you're dealing with high complexity simulations and calibration of high dimensional problems or products that have high dimensionality, you really can't get stuck and choke on data. Data has to be optimized and has to be quite efficient. So I'll hold off there because we've got a number of people here that have got great perspectives. I could go on forever.
Mm-hmm. So yeah, the hype may be more in this context on the big data than the machine learning side, but we certainly have some great opportunities with the right data. I'm going to turn next to you, Tim. Obviously taking that more to the factory floor, so to speak, into areas around maintenance and welding. Where do you see the real meat on the bone, so to speak, for machine learning and opportunities versus maybe where we're not quite there yet?
Yeah, so for us, one of the data sources we have is welding data, and there's data from everywhere that's coming in constantly, and we don't do enough of it. We recognise that as a company, and it's trying to get the good data, as Gary mentioned, and not just using all of the data to be able to follow up and get some actual real information out of it. So we want to be able to predict faults and look at failures before they occur, and using the data sources available, and in some cases, as we're working on the Weld Zero, to try and find sources that weren't there originally that we could potentially use and draw on.
Great, and we're gonna talk a bit more about that as we go through. But Katerina, I mean, at ATS and the project you've worked on, you're no stranger to data for sure. So can you talk to us a little bit more about where you're seeing the biggest opportunities in machine learning versus where there's hype?
I agree completely with Gary's point earlier. There's a huge hype about collecting data, but it's not just about collecting data, it's collecting the right data. And at the end of the day, you might not need all that data. So everybody gets very possessive about it, and they just don't know what to do with it, but they'll hold on to it as long as they can until they figure out whether there's something they can do with it. In a manufacturing concept, though, I think the biggest challenge for adoption of AI or any data analytics really is the deployment of these technologies and the scalability. It has been, different case studies have been proven in an innovation environment, in an R&D environment, but then when it comes to embedded within a whole factory, it's a whole different story. All these solutions and systems in place, they were not designed or put in place like these days. So obviously you need to retrofit a lot of the equipment, and this is the challenge really. How do you integrate all those elements together rather than just patching up and adding random sensors here and there to collect some data? It's how do you do it right with an existing facility. It's ideal if you had a brand new factory with a generous budget where you can start from scratch, but that's not the case for most of us.
Okay, and then I think, as I mentioned, when we look into some of the projects here, we can probably talk a bit more in detail about how we identify that right data. But before we move into that, Peter, anything you would add to what the panelists have said?
Well, I think the key is having the right data, and also machine learning is one of a number of tools to use to crack a problem. It needs to be used appropriately. It's not a cure-all. And also the representation of the data, it can be quite difficult to find your way through. The data I'm getting with the work with Tim is in a very good condition, but other parts of the project, 80% of the time is spent getting the data in a usable form, let alone whether it's the right data or not.
So clearly, quite a pattern there between it's quality over quantity of data. It's also having the right data, and there we also mentioned the data in the right format. And again, we're going to come into some of the specifics of that. I want to start understanding a bit more about or helping our audience to understand a bit more about Well Zero, as we've been referencing it a few times. And obviously, it's something Tim, Katerina, and Peter have been working on together. Tim, can you tell us a little bit about what the problem was that you're trying to address with this initiative?
Sure. So in BMW Group and across the world, one of the things we have is that we have the data coming in, and we want to be able to analyze it in a format that will give us a readable output. So we have weld expulsion, welding issues, failures in equipment. That all of this data comes from different sources, and we want to be able to use the relevant data from those sources to then be able to use machine learning, Industry 4.0, to predict what's going to happen in the future, or analyze the data a lot quicker than we would have done. So instead of looking at it historically, weeks later, we can look at it instantly, or maybe an hour later, to be able to say this is a fault that we need to be looking at before it causes us significant downtime or loss in volume.
And I'm interested to hear from each of the parties involved how, because we've heard a few times about the importance of the right data, clean data, etc. Talk a little bit about how the data is being captured and analyzed across these parties. And maybe Tim, you can start from BMW side. Katerina, you can talk about what ATS is doing, and then obviously we'll finish there with Peter to understand what's happening from Lancaster. So Tim, start with you again, and we can move through the process flow to understand better.
Yeah, so we have data coming from, let's say, different sources. So we have welding data, we have water flow data, all different data sources that are related to the welding process. And getting the information out can be quite easy, but getting the information out of the business, I think, as most of us can agree, with the current IT, it can be difficult to transfer data. So as you've mentioned, companies like to keep data secure and keep information secure, and we have to work through those problems with ATS, and they're designing a front platform that we'll be able to share the information with and view, which we're working with together with Peter.
I mean, Katerina, maybe you can speak a bit from your side there, and I know we also have a slide that perhaps can illustrate this a little bit as well. So maybe we can bring up that slide at the same time.
Sure. So what we're trying to do in the Well Zero project is really provide, as we mentioned, a platform that we can kind of connect and collect all that data and ensure an integration of different technologies together in a way which is agnostic and in a scalable way as well. There are lots of new machine connectivity solutions available these days, and probably manufacturers don't even know which one to choose anymore. But the real key to look after is really the configuration levels required and customization to adapt that solution. So this is, especially when it comes to retrofitting, sometimes it may not even work. So this is a challenge for us, is to enable customers and manufacturers to transition from a completely manual or semi-automotive environment into a fully integrated digitized process, which everything is linked together, it talks to each other, there is clear visibility about clean data, valuable data that can bring them insight, and everyone within the organization can get the message they need from that. It's not just siloed in one department or in one team.
Great, and so then we get a sense of how that works. And Peter, can you just round that off a little bit to talk a bit more about the way that you're then analyzing that data, sort of algorithm, building up that.
We're taking initially taking the data off a set of trials that are done by another one of the partners, which simulate the work that BMW are doing in their production line. But with these trials, we've got definitive inspection of individual welds to make sure they're compliant or not compliant. And we're using that to generate a model which is both predictive and classification. What we propose to do is apply that model to the BMW data and be able to predict the type of expulsion where it's likely to be, and then with the prediction look at changes through this process to detect when expulsion might occur and do something about it before it does occur. And one of the key parts to this is the data collection route that Katerina has talked about. So we would put the classification algorithm and prediction algorithm on the cloud, and it would use the data that's collected by ATS to populate our model and also to run the model on individual data sets.
So it's a very interesting project. You make it all sound so easy. I wonder how easy it really is. Tim and Katerina, perhaps can you give us a sense of what kind of bottlenecks, challenges you might face in sharing that data? Is it so seamless? Does it require specific plugins into your IT infrastructure to make it work securely? Tim, I'll start with you there.
Yeah, so there's a lot of processes and steps in getting the information out, and as mentioned previously, the IT departments and all big companies and smaller companies is quite keen on making sure the right information's given to the right people. So some of the blocks has been trying to get the information over to the ATS for them to actually be able to work with it. And we've been working with IT and ATS to come up with different solutions that work for both, that are easier to use. And with COVID and things that have gone on with that, it's put even more blockers because there's not people there. It's all virtual, so you can't necessarily all sit in a room. You have to try and explain your issues over Teams or other different platforms.
And Katerina, from your side, in terms of the systems that you built and used, I mean, were you able to use existing? Have you had to modify? I mean, again, how have you been able to achieve that?
We had various challenges. We have two use cases that we are exploring with BMW, and with one of them, we actually had to start from the basics. So we looked at eliminating the need for welding rework, and this process is currently manual. An operator would check if a rejected weld can be fixed through manual welding, and that would be it. What we did is we digitized this process, and we're now collecting the inspection data to be used for analysis by Peter. And this way we can identify areas for improvement in the production line. We can now see the percentages of recurring defects, which drive the root cause analysis and provides clues on what process modifications are required, etc. Then we can start adding the necessary sensors and looking at the additional architecture around it required in terms of edge computing or what else do we need to modify within the manufacturing process. So I guess the key learning for us here is to define what the problem is that you're trying to solve. There's no one size fits all. There are lots of learnings, of course, but you need to kind of understand what the whole data, what data do you need to collect, and therefore this will define your solution. So yeah, a lot of people are made to think that you just need to connect and collect everything you possibly can, as I mentioned earlier, but that's not the point. Data collection should come always with a very well-defined problem statement that you're trying to resolve. So the adaptations required really depend on each individual use case. Of course, the basics about collecting data, visualizing it, understanding it, cleaning it, making insights is standard, but you need to follow that process for defining the problem you're trying to solve.
So before we get into a few outcomes of that as well, and afterwards we'll talk with Gary a bit more about some more specific side from you. But Gary, I'm keen just to hear your impressions and a comparison of your experience in terms of what you've been hearing there, just on the edge, cloud, different data standards, the way that it's shared. How does that sort of compare to your experience at Secondmind and other companies in the area?
For Secondmind for us has been, it's purely cloud. So we're doing offline modeling and with the access to the data that we get from our OEMs directly. And back to the point about less data or the right data, when you're shuttling, what could potentially be terabytes of data in a given period or short period of time, but that could create huge bottlenecks from facility to facility. That's one thing, but when you're dealing with a vehicle and trying to capture real data, that becomes more of a problem. But for us, we're able to use up to 80% less data for, let's say, the design of experiments process for calibrating an engine or an EV motor inverter, and pulling that data directly from the sources, whether they're a numerical simulator or a live test bench, up into the cloud. It's relatively straightforward. In my experience at Qualcomm, there was a vision, and I think that still exists today. In fact, the teams at Qualcomm, whether it's the data center or the mobile devices or vehicle, there's the shared effort of training models, collecting data, executing the models to infer what's in the field of view of a camera, or any of the data that's coming in that has to be interrogated to render a prediction. There's almost like a circulatory system as everything's fully connected with 5G. Everything has enough compute and access to data and be able to run models proximally in the cloud or what have you. It's a pretty exciting time, but it's also quite scary and complex. So if it's purely cloud bound, it's a little bit easier to control. But when you're dealing with nodes and the vehicles and the cloud or the fog in the middle, then it gets a little crazy.
Thanks for that, Gary. And like I said, we're going to come to a couple more specific topics for Secondmind, but just turning back on the Weld Zero for a moment or two. Tim, did that, we've talked again, what Gary just said there about actually being able to reduce the amount of data sent to the right data. Have you kind of, in this process, kind of been able to identify, in effect, what you don't need to send anymore? Kind of, did you start off sending everything and then you sort of found the way to just the exceptions, or is that something that's still evolving with the project?
Yeah, so it's definitely something that's still evolving with the project, but we're also finding data that we do need. So data that's missing that would be useful. So we've created ways of getting the data information for that, which ties in with the welding data and other bits of information. So it helps us to understand exactly what's going on in the process and identify risks before they happen. So it is still work in progress with Peter, but we're sort of, and one of the things we have is in Oxford we put on over 1 billion welds a year, plus all the other information. So there is a lot of information floating around, and it's making sure that we're not overloading it with stats. So we're concentrating solely on a couple of robots as opposed to the whole body shop to try and make sure it works, and then relaying that information with the other parties that we're working with to see if the analysis shows the same results for them offline as it does online in production.
Yeah, and Peter, as the slide we showed earlier showed, obviously it's not just coming from BMW. There's other parties involved here as well. So in terms of comparing and contrasting how the data standards and formats come, is that something you've had to work out, and is it BMW kind of further along than others, or how does it kind of look in that picture?
Yeah, it's a mixed bag, really. I mean, BMW is further along because they provide some machine output which is fairly consistent, and we get that through ATS. But some of the other projects, the data is rather spurious, trying to tie it together for different parts of a process. Simple classifications that are quite different in different files, different projects. So one thing it's done for me is it's made me realize that you need to have a standard of data quality, and the framework it sits in to enable you to efficiently model it and use it for machine learning.
Okay, yeah. So again, that point which is made right at the beginning. Clearly, those lessons continue to be learned. Before we maybe move on from the Well Zero, I mean, Tim, is there any kind of early outcomes, learnings that you've already learned from in terms of your actual operations, in terms of the machine learning, what it's showing you how to avoid defects that you could sort of share in terms of or outcomes or results, or is this still ongoing, really?
From an Oxford side, there's not the outcomes, but we do have the outcomes coming from with Peter working with one of the other parties who are looking at some of our big faults we get that we see, and we're analysing the data by recreating these in a lab condition to see if we can then see what's happening with that to then be able to recreate them in a serious condition and compare whether we can use the machine learning to be able to predict these. So be it an edge weld or other welding conditions that happen, poor setups. As a project team, we identified the big hitters that would be perfect to pick up on and then replicate them. And one of the things we've learned with that is that we need more material samples. So we increased the material samples from just being a set condition of 2 thin sheets to then having a thick sheet and thin sheet to analyze the data on that, which Peter's working through.
Okay, interesting. And Katerina, any sort of from your side, next steps, how this should evolve next? Where does it go from here, from your point of view?
I'll probably summarize Peter's point quite strongly that we need standards. So in order for such systems to be easily and quickly deployable in a production environment, we all need to be aligned on the data standards being used. At the moment, every organization has their own data model standards, but that doesn't make them global, which means the supply chain as a whole needs to adjust their offerings for each individual organization, and that obviously takes more time and more effort and makes these solutions more difficult to be deployed. We also need standards for business processes beyond the best practices that are currently available, which will enable the management, integration, and ownership of all the activities around new technology introduction and change management setting. And that kind of leads to the security as well, which I know is a kind of a hot topic too in that element. Many organizations just don't know whose responsibility is it, what's the process, who's the owner. So it's establishing those expectations and standardizing the processes and generally what needs to be done.
Okay, fascinating. Thank you so much for sharing. Of course, we can turn back, but Gary, I wanted to turn to you now a bit more on the work you're doing with OEMs. I know you're working with the likes of Mazda on design engineering of powertrains. You mentioned earlier this is all cloud-based, so that side of it. And so tell us a little bit more about how the processes you're working on are helping OEMs to get these products to market into production faster. You're muted, Gary.
Sorry, there was a fire truck or something in the background. I turned on mute. When we started down this journey, we've been a machine learning company at the core, and we've experimented in different industries, and automotive just happened to be this really good sweet spot where the marriage between the way that we practice or the techniques we practice and the type of high dimensional problems from an engineering standpoint, design and development, there was just a really good match. And we kicked off this journey with Mazda after experimenting in other spaces. And the initial premise was to try to find ways to streamline the calibration, the control system calibration process, both of legacy control systems for an engine, but also EV motor inverter, the hybrid control system, et cetera. Try to find a way to wring out as much inefficiency in that process to compress the time, hopefully reduce the amount of materials and the glut of data that's there that is associated with the way it had been done previously. Try to compress all that time and streamline that so that the time, the manpower, and even the materials are saved. So all that investment can be pushed forward into strategic areas of investment that are related to, connectivity and autonomy, broader electrification, and then this future software-defined vehicle. when the processes have just, and the way in which the products are developed, and keeping legacy components like ICE on the road, for the next 10, 15 years from where we are now, balancing those two things is it's a difficult problem to solve. It's not just the way things are done is not sustainable, both from a business and environmental standpoint. So we zeroed in on this one use case, which is around the calibration of an ICE, of an internal combustion engine, and then EV motor inverter. And we found some really remarkable results in reducing data. It was like 80% less data in the mix. We could go through the experimentation process and the calibration process in half the time, and then save 40% of prototypes that would typically either seize up on the bench or end up getting destroyed throughout the process because it takes so long or just wear down. Again, being a machine learning company and trying to solve all problems, focusing on automotive was the right match, and that's how we got our start and our foothold.
Can you talk a little bit more about what kind of machine learning processes you're using?
Yeah, so I guess the high level descriptor is that we practice a technique called active learning, and the way that we implement that is through some basic probabilistic modeling using Gaussian process, and then Bayesian optimization on top of that, which is really how we filter out most of the noisy data, the sparsity in the data, to find the signals in the noise, if you will, the right stuff to work with. And the process really is a combination of the algorithm that knows where to find data for the next experiment on its own, based on a profile that an engineer has set up at the beginning. And the algorithm, the platform, goes through the process of identify the data in a region of interest, bring that data back, add knowledge to the model goes and finds another region of interest. So there's knowledge that's accumulated, and you don't wind up with 100 or 150 different models to choose from. The end result is you reach a global optimum for the calibration map in half the iterations, again, 80% less data. And there is an interaction or a collaboration between the intelligence of the algorithm, but also the subject matter expert, the engineer, is able to inject knowledge that is not baked into the data, intrinsic knowledge based on their experience, to stop the process, change something so that if it doesn't feel right, doesn't look right, they've seen something before that's not the data, collaborate with the algorithm, you wind up with a much better outcome.
Okay, that's interesting. Again, I'm interested to kind of compare, contrast a little bit from our other experts. Peter, in terms of the machine learning approach, algorithmic approach that you've taken, how does that compare and contrast?
Well, for what I'm using for a lot of these cases is a classification methodology, which is quite a bit simpler. I'm also using some windowing methodology that takes a signal and breaks it down into windows and calculates some values for each of those windows, and it generates features, salient features for the model. So the work is not as high dimensional as Gary's from the sound of it, but it's really trying to use the right method for the data for what the outcome is. And it's all about when you start this process, your customer, i.e. BMW, needs to be aware of what they want as an output.
Yeah, and that's a point Katerina mentioned earlier, knowing the problem you want to solve. That's obviously really important to this. Tim, did you feel that that was my first question to you at the outset. But do you feel that it kind of has evolved as it's gone along in terms of what other issues you wanted to address?
Yeah, so having this sort of looking into the data, it makes us understand that we have got an awful lot, and it's being able to, as we've mentioned all along, drill down to the correct data. And working with Peter and Katerina, we've managed to sort of isolate what we need to be transferring, and it's helped us address our problem of weld expulsion and trying to look into it. We've had some initial results which look promising, and it's still work in progress, which we're working through on the project team until September when it finishes, and we're hoping to get some results in the next few months that'll be very promising.
We look forward to hearing more about that. Gary, you mentioned obviously the initial work on the calibration for the ICE engines, but you did mention getting into also hybrid and the electric motors, etc. How does the machine learning algorithms and the models for ICE kind of help you for the electrification, electrified products as well?
I guess the approach we take, to simplify it, we look at the problem as a number of parameters and constraints in the optimization process or the calibration process, where you may have parameters that are germane to ICE, whether they're physical properties or emissions regulations or fuel efficiency. And then on the electric side, you have temperature, you have the utilization, a number of different factors, but our system's agnostic. It's just a matter of how many parameters and constraints you have. We need to understand a little bit more about some of the characteristics up front before really get into production. But the way that we've designed the platform is that it can be pretty extensible, and it really excels with high dimensional problems. We're seeing some that we've not seen before in terms of the level of dimensionality, but it really doesn't matter whether it's an internal combustion engine or it's a EV motor inverter or any other control system in the powertrain or in the vehicle. We try to abstract the actual application is pretty versatile. And this is just at the hardware in the loop phase in the design and the development process. The same underlying approach or the same underlying technology, the active learning core, if you will, can also be applied to early design after the vehicle has been spec'd out. You spit out a Simulink model of the vehicle and all the systems and components. The optimization of let's say a hybrid system or other complex system to winnow things down during the feasibility and validation process to the most precise outcome, the most precise configuration of a system design. You wind up with a level of precision that then prevents a lot of rework to go back in the process, and you can get through the rest of the production cycle or the development cycle faster. There's a whole movement that we've been seeing around trying to virtualize the left half of the V model, and what we're doing right now seems to be pretty applicable across the board.
Okay, thank you. I want to look ahead, spend the last 5-10 minutes, if you like, looking ahead a bit. Tim, I think you mentioned that the transfer was a mix between edge and cloud, and I know that BMW is implementing a wider industrial cloud network. I don't necessarily think you were referring to this being on that as yet, but will that approach help to capture and share data like this much more seamlessly? Connecting in with providers like ATS.
Yeah, so BMW Group are sort of using the edge and the cloud a lot more for all of their data analysis and different projects that we're working on with all different groups. And we recognise that having stuff in the cloud makes it easily accessible for everyone, and it's a safe storage place to keep the information. It also gives us, not never ending, but it gives us more opportunity for storing information as opposed to having it on local networks. We can store the information and keep longer time. So we're finding rather than having 3 months worth of data, we can store 6 months, 9 months, 12 months worth. And as I mentioned earlier, we produce an awful lot of WOWs and other volumes each year, and that information can fill up quite quickly. So it's being able to access it quickly and being able to work with it.
Katerina, we haven't talked about it too much in this session, but another initiative you've been closely involved with is, I mentioned at the outset, 5GM, the 5G-enabled manufacturing. Is 5G something you see as really the next step to power charge, or a next step to power charge, machine learning, and eventually also artificial intelligence in manufacturing?
Sure. I think first that 5G is an incredible technology that can connect so many places together, so many devices in an easy way. But I still think it needs to prove its value in a manufacturing context based on our learnings from a project that we had with Ford and Vodafone, where we deployed a private 5G network. And in that situation, we deployed some data analytics and AI into the welding environment, into a welding process. So what we came up with was that there's still limitations such as the upload speed. That's very different to a commercial need. So normally when you're at your home and you want to watch a movie, you're interested in the download speed in terms of streaming it faster. In manufacturing, you're doing quite the opposite. You're just constantly uploading stuff into the cloud. That hasn't been quite tweaked yet to match the industrial requirements. There are lots of other security elements that need to be resolved and all that. But in general, personally, I think the 5G would have great potential for mobile objects or products, especially for offshore or remote manufacturing or even maintenance operations. So from the automotive sector angle, 5G could possibly bring huge business potential by integrating smart parts within cars capable of streaming live data directly from millions of cars all over the world that are on the road. And each individual company, not just the OEM, but also its supply chain providers, can get enough data and insights to improve their services.
Okay, thank you. Gary, is 5G something that will also make a big difference for Secondmind?
In the short term, no, because what we're doing is all offline, cloud-based. But the future of the software-defined vehicle, where you really have a massive high-power compute, data processing, fully connected vehicle. 5G makes it possible to be able to move quite a bit of data, make sure that it's efficiently moved, but quite a bit of data to and from the car, where you can do some processing, some modeling, some execution on the car itself or in the car itself. But for us, we still see the cloud and being connected through 5G to the cloud as being able to handle the processing that we're doing with our technology. But it's early days for us, and I think the cloud to edge equation is one that's fast evolving. So we'll probably see processing on both ends.
Okay, great. And Peter, sort of building on the sort of data sharing that you've been involved with, both in the Weld Zero and as also Lancaster University as well in the 5G. Is this an opportunity to create more advanced artificial intelligence solutions, at a wider sort of industry level with this sort of data sharing?
I think it is where there's a standard data pool. It's easy to get the data around. I think one of the things in manufacturing is going to be predictive control and turning out to open to closed loop. So you can actually see something's about to go wrong and fix it before it does go wrong. That would be the ultimate.
So please go on.
It's the cloud platform is really a data repository for research, or I see it that way, coming from the university.
Tim, for Oxford, is there steps already or any predictive maintenance areas that you're already involved in?
Yeah, definitely. So not just from a welding point of view, we use it a lot with our maintenance to look at our equipment, and we've got different solutions. We're working with different companies to be able to predict failures. So we're working with our weld gun supplier, to be able to highlight faults and flag it up, and the platform that we use that is being developed all the time to try and make it easier and more user friendly, so that we can look at it and say this is happening and react to it. And it's very new to us, so it's sort of in the last year, so we're still getting to grips with it, but it is proving to be a lot more accurate than what we were expecting, to be able to use predictive maintenance along with lots of other tools that we use.
Great. Again, another exciting area we look forward to sharing more with our audience about. Just a closing question so before we go to each. Katerina, What do you think manufacturers should do kind of now in the short to medium term to improve their IT setup and systems to really allow for a smarter connection of data to optimize the things we're talking about here?
I think the key is really changing first the mindset about data and getting everyone to open up their data. The trend about big data and its value has made everyone lock up their systems and make it as hard as possible to connect to a machine or get any useful data out of it. And that's including the equipment being used and the machines in a manufacturing environment for the automotive industry. So what we really need to get is trying to understand who has ownership of what data, trying to establish the processes in place and standardize them across the whole supply chain, not looking at it just from the individual organizational perspective, but kind of trying to drive a digital data-driven culture across the supply chain. So that's kind of establishing a sharing culture really about it, and making sure that everybody gets access to the data dedicated to them for maximizing their value, that somebody else by holding it wouldn't get anything out of it anyways, and kind of collaborating together really. I think this is the first step to start with, but then it's just starting with establishing their connectivity levels, trying to bring all their equipment into a network on the shop floor. And that means that sometimes we need to add an additional layer to connect to certain retrofitted devices. This is doable, and we have demonstrated that, so it's not far-fetched high tech. And then making sure that they can integrate that data with their IT systems, MES, ERPs, everything else they're using in the shop floor, and also making sure that they take into consideration the individual people working on every line, because they will see things that the higher level of the groups working on these initiatives won't really pick up so easily. So involving the people that understand the process is a lot better.
So some great points there around integration, but obviously your initial point, the importance of culturally being open to sharing, not seeing all that data as a competitive factor, but in fact an area that the industry can gain from. Tim, if we look out a little bit, I mean, besides hopefully getting some great results in September that really help, clearly you're welding and reducing defects there. If you were to think a bit further out, let's say over the next 5 years, what would you describe as your ambitions to use data analytics, machine learning, even AI in your production and maintenance areas?
So again, we have so many different machines that produce data, and they all talk in different languages to different platforms. And one of our key aims is to try and get a solution that allows them all to communicate into one portal, which you can then look at, because we recognize that there are faults that then the key to predicting them is to be able to look at all the sources and bring them together in one platform and be able to pick them out. And part of that is, as Katerina mentioned, is getting the sort of buy-in from everyone. And a lot of the red tape with any of these comes with all the different departments that have to be spoken to share the information, can take an awful lot of time. And if we can get that process a lot more smoothly, it will make it a lot easier.
Fantastic. And Gary, just my last question for the panel goes to you. You mentioned you're at the start of the journey here for Secondmind, but if you look out, 3, 4, 5 years, what's your ambition for your approach to machine learning or beyond to AI?
I think our ambition, the thing what we'd like to achieve is get as close as we can to what our purpose is. One would call it a vision, and that is to help the innovators who are trying to transform the automotive industry overall, build better, cleaner cars faster, and ultimately achieve their sustainability, whether it's business sustainability or environmental sustainability through machine learning, which we talk about machine learning and artificial intelligence, and another underlying objective in that is to strip away all of the ballast, the fear, the uncertainty around this breed of technology, which is just new software. If we get our heads around it that way, there's really nothing that gets in our way. And I think generally speaking, sustainability in process manufacturing across the board, machine learning is going to be the primary catalyst for sustainable businesses and production. So for us, we want to have a hand in that and be a big catalyst for helping the industry get to the other side of this journey to carbon neutrality. And we're going to do it starting with the design and development process and move forward.
Well, great. I think that's a great note to end on with some of those ambitions and tying that mission, of course, to the wider sustainability goals of the automotive industry. I really want to thank all of our experts today for their time, input, for talking through these case studies and these real examples. We had a lot of, they're quite different perspectives in terms of the projects, but I think the underlying themes were so united around data standards and being open for that side. So really great, really interesting, really enjoyed that. Thanks so much, Katerina, Tim McGrath, Peter Wilson, and Gary for your time today. And thanks as well to our audience for joining. We'll have the session available on demand. And obviously any further questions or connections you want to make to our panel, do this on our online platform or get in touch. We'll be happy to connect you. But thanks again to everyone.
Thank you, Chris.
Thank you very much.
Thanks.
Thanks, everyone. And stick around, everyone. We're back here in 10 minutes talking about the future of production planning, looking at digital twins for the last session of the day. So we're looking forward to that. Thanks, everyone, again.